It says a random sample of 45 life insurance policyholders showed that the average premiums paid on their life insurance policies, $340 per year, standard deviation of 562. So this is a good place to start with where it says on your on the board there, identifying variables from the story. Like can you, and this is where I guess I'll just highlight them or circle them. Like what's 45? What's 340? What's 62? What's 90? And then not only, what, like basically, is it a, what thing goes with it? Like letter or symbol?
Okay.
So does, I mean, we got 4 there. I mean, if we can get a couple in the first one, that'd be good. But any of them stand out to you? Like, okay, that's the blank. That's the,
The standard deviation is $62.
okay, and what letter do we use for that? And we'll assume that this is the sample standard deviation. Well, it does say sample, so there you go. Remember which letter that is?
Oh, it's
So
like
just,
a lowercase.
yeah, it's just S.
Okay.
Now, if for the population, I will just note that here, that's the Greek letter, sigma.
Yeah.
Okay. All right. What else do you see?
The confidence interval is 0.9.
So that's C. It's not really one that he's talking about there, but good to know.
The is
What's the
the
40?
average?
Yeah,
Oh, is the
average.
average 340?
It is the sample average. Do you remember what letter goes with that?
I don't.
So this is X bar. X bar is 340. For the
Oh, yeah.
population, it's mu.
Which is 45.
In this one, 45 is the number of samples.
Oh,
That's
okay.
n,
Okay.
little n. Big N, which you rarely see, is for the population. Is that okay?
Yeah.
All right. Keep in mind for sample, they're typically letters, alphabetical letters. Population is Greek letters.
Okay.
All right. Now they've given you the answer, which that's great. That means we can calculate we just need to calculate. Now, are you going to get a formula sheet? Are you going to have to come up with the formulas? Give me more information about that.
We're allowed to have like one sheet of paper for like a little cheat sheet.
Okay. Very good. The main ones that I'm seeing that come into play here would be good to have in is I'll snip that in. That didn't snip well. Okay. So these are the main ones that you might need. This one, you kind of have to go off of what am I given? You're given the standard deviation sample, S. So you're looking at either this one or this one. And the way you decide is based on sample size and the fact that the population standard deviation is unknown. So in this problem, we're looking at this one here. Now you also can use your calculator, I'm assuming.
Yes.
Okay, so this is a T distribution. All right, so this is going to be a T confidence interval. Do you have your calculator out? available?
Yes.
All right, I'm getting mine out, the virtual one here. Right, so your share, get that up in front of you. Okay, to do this one, it's under stat tests, and then you want the confidence interval for a t. So we're looking for a t interval, which is number 8. And then you have to choose data or stats. This is a stats because we don't have any of the data. So you need
Mhm.
the average, which is 340. The standard deviation, which is 62. The sample size, which is 45. And the C value is 0.9. Important thing to remember here is if you don't have a value that the calculator needs, a couple of possibilities. One is you might be using the wrong test. So that's something to think about. The other is that maybe you just didn't find it in the problem, but just keep that in mind. Should be all sync up there. So when you hit calculate, hopefully you're up to here.
Mhm.
You should get 324.5, 355 point. I mean, very close. I couldn't really say what the difference is. Maybe the instructor used a different piece of software. Maybe they rounded something somewhere along the way, but close enough.
Okay.
I mean, we're within 0.1. Any questions on that?
No.
Okay, let's go back to the other screen. Okay, so I'm just going to grab another problem, do the kind of the same format here. Do you have any of your reference sheets from your old exams? If you guys got one, sometimes those are good to
Um,
use for.
I don't know because he collected them and didn't give it back to us. So I don't
Oh,
have any of my old material.
all right. Well, that answers that.
Yeah.
All right, process has been developed that can transform ordinary iron into a super iron called metallic glass. Metallic glass is 3 to 4 times stronger than the toughest steel alloy. To estimate the mean temperature mu at which a particular type of metallic glass becomes brittle, 25 pieces of this metal were randomly sampled. During reaching production run, each piece was subjected to a higher and higher temperature until it became brittle. The temperature at which the brittleness first appeared was recorded for each piece in the sample. The following results were obtained. X bar 480, S is 11. Construct a 95% sample interval to estimate mu. All right, so this is actually the same thing here as the previous problem. So there's not really much different. If you don't mind, will you use your calculator and do the same thing? Do that t interval again and make sure you get something really, really close to what is here.
Okay.
Get ready for the fight of your life. You're not gonna fucking win this.
I got 475.46 to 484.54.
All right, really good. Those look great. Okay, so let me do one more of these identification problems with you where you come up with,
No, shut up.
you look at the letters, sorry, you look at the numbers and then see that,
Stop talking
tell
over
me,
me.
tell me what those are, kind of like, are they is it, S, is it P, is it C, is it, anything else?
Yeah.
It would help if you could see it. There we go. It's number 15 on that piece of paper you sent. So in any order, just read it over, see what you think.
Sucks so bad. You fucking ran into him. All you had to do.
What do you think? Any of these values stand out? Like what is 100? What is 2130? Any of those kind of mean anything?
The sample size is 100.
Okay, that's little n.
Mm-hmm.
Okay, that's also important.
The um X bar, the sample mean, that's 2130.
Good.
The standard deviation, little s, is 578.
Okay.
And then the interval is 0.97.
That's something that might go on your reference sheet, is that C is equal to 1 minus alpha.
Okay.
So if it asks for a confidence interval of 0.97, the alpha level is 0.03, for example.
Okay.
All right, now we have not done a proportion confidence interval, and there's one kind of little wrinkle with your calculator that it may or may not be able to do. And I believe this is the one that has that little wrinkle. So it says that in a Times CNN telephone poll of 1,012 adult Americans, 11% of the respondents said that Ronald Reagan was a great president. Given 98% confidence interval for the proportion of all adults who think that Reagan was a great president. Okay. In proportions, and this is a proportion, you have your P, which is X over N. Yeah, I guess is the way to do it. X is like the number that are in favor. N is the total that they sampled. But what they do sometimes, and they're doing that in this problem, is they give you that it's 0.11. N is 1,012, but they don't give you X.
Okay.
So it's like, well, what do I do? Well, you can calculate X,
Lay down and everything.
right? X can be calculated from this formula. X is N times P. And that might be something else to write down.
Mm-hmm.
So in your problem, X is 1,012 times 0.11.
So you use to find the proportion interval, you use x equals n times p.
Well, you're gonna see in your calculator that your calculator wants an X. And we're gonna see what the problem is when that happens. So,
Okay.
yeah, so could you calculate this 1012 times 0.11?
Um 111.32.
Okay. All right. So now we're gonna go back to the calculator. And I'm going to share that screen. Here we go. Turn the calculator back on. Stat test. This is a one sample, or it's a proportion interval. Sorry, I'm losing my place here. Okay, there it is. One prop Z interval. Letter A. One proportion. So see how it wants an X and an N. So I'm gonna enter this 111.32 divided by 1012. Confidence level is 0.98.
Like you're stupid ass, you fucking suck at that.
And then when you calculate, you're gonna see there's an error. I don't know if you remember this from when we did this a while back in the course. Why is there an error? It's because the X has to be a whole number. So this X has to be a whole number. So as soon as I make it a whole number, it will work, but we're not supposed to do it that way. But I'm gonna go ahead and enter for calculate, and you'll see that it does work. Okay. Now, will it get you close enough? Probably. Do you know if your final is like multiple choice? Free response?
It's free response, but he's pretty lenient with it. As long as you get pretty close to the range, then it would be fine.
Okay, so I take that so now you know, I mean that now you know if there's an error, what to do. You're going to make that X into a number that's close enough.
Okay.
Does that make sense? Reasonable.
Yeah.
Okay,
How does that work with math if it's not exactly?
all right, so let's look at number 14. I'm gonna go ahead and share the other screen here in a moment. And then we'll move to type 1 and type 2 errors after this. Okay, so here's a problem that looks like your handwriting. I'm guessing it is. The way you've done it here is by hand. And that's great, right? But we just talked about the fact that you can do it in the calculator. And what I'd like you to do here is read the problem over and figure out P, X, and on, please. And one of them you will have to calculate like we did in the previous problem. How are you doing on this? What's the value of P, X, and N? Any of those?
So the value of n is 3000.
Okay, good.
The value of x is 0.56.
So P is 0.56. P is always the proportion or probability. It's always gonna be between 0 to 1, or it's gonna be a percentage.
Oh, okay.
And just like the last problem, they do not give you X, so you have to calculate X. X is N times P.
Oh, okay. So 1680.
Okay, and this is nice. This works out just fine. So I'd like you to go to your calculator and do that one prop Z interval.
The range is 0.53892 to 0.58108.
All right, so I think that's kind of gonna do it for that part of the lesson. We'll come back if we have time on other stuff. The next thing we should look at are is type 1 and type 2 errors.
Okay.
And I think this is a really good diagram. We're going to specifically talk about a type 1 and type 2 error, but this actually addresses all the possibilities that you could see. So a type 1 error, very succinctly stated, is when you reject the null hypothesis, reject H0, that's the null hypothesis, but it's actually true.
Okay.
So I can't help but think of just scenarios that like happen in real life where we think we reject something, but it's actually true. And I mean, I don't know, I could think of some if you'd like, but that's the key kind of thing to remember. The type 2 error, that's the other one here, and for whatever reason they use Roman numerals.
Okay.
Okay, is when you fail to reject H0, but it's actually false. Those are the two main ones to remember. The other correct decisions come up on occasion, but maybe not in your class.
Okay.
So the next thing to do is to actually look at some problems here and decide, like, is it a type 1 or is it a type 2 error? Which would be great if I could find. I thought this one had some example problems. It did not. Okay, so give me a moment here to find some. Is the difference between them clear? Like, do you feel like you understand that?
Yeah.
Trash.
Wow, I just can't find like what I'm looking for, which is they give you a scenario And then you have to decide if what they're saying is a type 1 or type 2 error. But let me just grab one here. I apologize. I know it's maybe the font's not super big to read, but here we go. All right, a clean air standard requires that vehicle exhaust emissions not exceed specified limits for various pollutants. Many states require cars to be tested annually to be sure that they meet these standards. Suppose state regulators doubly check a random sample of cars that a suspect repair shop has certified as okay. They will not revoke the shop's license if they find significant evidence that the shop is certifying vehicles that do not meet the standards. Okay. Let's just say for the moment here is that the null hypothesis is that the shop is actually like, well, let's test the claim. There's the claim is that the shop is maybe lowering standards.
Okay.
That's kind of what's implied here. Let me know if my internet or if the call quality here is down. Looks like I might have an interruption in my internet.
Oh, okay.
Okay, so a type 1 error in this context would be rejecting H0, but it's actually true. So in this case, it means that we're like the shop, like we're rejecting H0, which means that we're supporting the alternative. We're saying the shop is lowering the standards, but it's actually not true.
Okay.
And they might ask you to write a question or write an answer to a question like that.
Yeah.
In a type 2 error, you fail to reject H0, but it's actually false. You say, oh no, they're not lowering standards, but then the test says that, but you actually find out later on that that they're lowering their standards to make sure more cars pass.
Okay.
Okay, let me try to find a better, I didn't mean for this to be
Eric, back.
the scenario is very important is what I'm trying to emphasize or
Mhm.
find one that kind of emphasizes a scenario that's somewhat reasonable for us to take an interpretation of. So Captain Ben flies small passenger jets. These jets carry 50 passengers plus their luggage. On a full flight, these jets will perform properly long as the total weight of passengers checked baggage does not exceed 5,000 pounds. Ben is concerned that the passengers on a particular flight have brought unusually heavy bags. He selects a random sample of 10 passengers and weighs their checked baggage. Based on the results from the sampling, must decide whether it is safe to take off. So the alternative hypothesis here is that the weight is greater than 5,000.
Okay.
And the null is that the weight is less than or equal to 5,000. Okay, so this is safe and this is bad. Like, I guess this means that the jet will not perform properly, which definitely don't want that. So let's talk about what a type 1 error would mean.
Okay.
So a type 1 error is when you reject H0. So what would that mean in this context if you reject H0? What are you saying about the weight of the bags?
If you reject the safe options, so So that would be if it doesn't exceed 500 pounds, right?
We're rejecting that it's less than or equal to 5,000.
Yeah.
So what does that mean? What are we supporting then?
You're
Support-
supporting the,
Yeah, the other one. Yeah.
yeah.
And what is the other? What does that mean in this context?
It's like the other one that it will still fly if it's over 5,000.
Well, we're saying that we think like let's say you're Ben and you make a type 1 error. That means you're rejecting that it's less than 5,000 and you're saying there's more than 5,000 pounds. Well, like what does that mean in this scenario? Like what are you gonna do? If you can't fly if it's more than 5,000 pounds.
Um,
I hope that he's better than me.
You ever been to the airport and someone's got like too many bags they're trying to bring onto the plane?
yeah,
What do they make? What do they make them do?
they make them consolidate them.
Yeah, exactly. Well, that's what's happened here. Ben's gonna say, hey, you guys got too much luggage. Set some stuff aside. Okay.
Okay.
But is he justified in doing that? He's rejecting H0, but it's actually false. No, but it's actually true. I'm sorry. H0 is actually true, meaning the weight of the plane is actually less than 5,000. So is his action justified? Like he thinks it's more than 5,000, but it's actually not. So should he be going and telling passengers to, uncheck their bags or consolidate and all that?
No.
He doesn't have to. Yeah. And that's the danger. Okay.
Yeah.
Okay. Now a type 2 error. Type 2 error is when you fail to reject H0. So you fail to reject it, but it's actually
Okay.
false. What does that mean in this scenario when you fail to reject that it's less than or equal to 5,000?
When you fail to reject when it's less than 5,000.
Yeah, but it actually is more than 5,000. What's the problem in that scenario? You think it's less than or equal to 5,000, but it's actually more than 5,000.
So that's a type 1.
No, we're on a type 2 error.
Oh, type 2.
You fail to reject H0. What that means is you believe that the weight is less than or equal to 5,000, but it's actually more than 5,000.
Uh-huh. Then,
I'm thinking maybe of just switching the scenario up here because I don't know that this is making sense, but like something that would be more applicable to you. But they think the weight is safe, but it's actually not.
then it like can't fly.
Well, they don't know that though, right? They're thinking they're good.
Oh, I'm confused.
Okay, let's take a different example. H0. Do you have any food allergies? You don't have to share many, but like, do you have any like specific ones just to kind of make this make sense?
No, I do not.
Okay. So let's take someone that has like a peanut allergy. That's a kind of a common one. And we're gonna make H0 is that the dinner has peanuts,
That's actually crazy.
and H1 is that the dinner does not have peanuts. Okay. So try to think through what happens if you have a peanut allergy and you think that the dinner has peanuts. Okay. But so you reject that the dinner has peanuts, meaning you accept that it does not have peanuts. Is that okay if you have a peanut allergy?
Wait, so if the dinner has peanuts, then you reject.
So let's talk about type 1. Let me be more specific. You reject H0. So what when you reject H0, what does that mean for the problem?
So when you reject H0, that means that the dinner does not have peanuts.
Does not have peanuts. Okay. Okay, but it's actually true. So you think that the dinner does not have peanuts, but it actually does have peanuts. Is that bad? If you have a peanut allergy?
Yeah.
It's really bad. Okay.
Yeah.
Type 2 error is you fail to reject the H0. So you don't reject it. So you're sitting there, you're saying, you know what? The dinner has peanuts. Okay. But it's actually false.
Okay.
So the dinner, you don't reject this. So you think that it has peanuts, but it's actually false and it does have peanuts. Is that bad?
If you think the dinner has peanuts in it, but it doesn't.
Yes. And assume you have a peanut allergy, like or you say, up dinner has peanuts. What are you going to do? Are you going to eat it?
No.
No. So it doesn't matter that you fail to reject in this case. Like, so there's always a scenario where it's kind of okay. And let's try it with another scenario here. Okay. Prom dress. Okay. What's the concern most, people have about their prom dress?
If someone else is gonna have the same dress.
All right. I'm thinking of the guy. I was thinking about fit.
Oh.
All right. So my guess is that there's always this concern that it's too small.
Okay.
So let's just say that means, and I don't know waist sizes, but let's just say we're worried that it's less than 26 inches. But the manufacturer claims, hey, it's always going to be more than 26 inches. Okay. So prom dress, this is the claim. This is what we're concerned about. We're concerned about what happens if it's less than 26 inches. Again, I don't know if that's big or small. I really, just forgive me if that's way off. So a type 1 error is when you reject H0. What are we rejecting?
You're rejecting the claim that it's bigger than 26 inches.
Okay, so we now think it's less than 26 inches. Okay, but it's actually true. It's actually more than 26 inches.
Okay.
So if you buy a dress and you then reject this, you think it's actually less than 26 inches. What are you going to do as a result of that?
If I think it's bigger than 26 inches, but it's actually.
Well, you reject that and you think, oh no, it's now less than 26 inches. I need to go on a diet, right? Got to lose some weight or do something, right? But in reality, it actually is fine. Was that justified?
No.
You didn't actually need to do that
Yeah.
because it was actually like, okay, right? So
Yeah.
type 1 errors are typically like preferred. That's another thing I want you to think about putting down. Now let's talk about a type 2 error. You fail to reject H0. And I think this is the the one wedding dress, prom dress. This is the bad scenario. So you fail to reject this. So what do you believe to be true when you fail to reject?
So when you fail to reject that it's bigger than 26 inches.
You think your dress is bigger than 26 inches, but it's actually false. What does that mean in this scenario?
If it's so if you fail to reject it's- then you buy something that is less than 26 inches.
So you think the dress is going to fit.
Yeah.
You think it's going to fit. And you're going under the assumption that it's going to fit. But what happens in reality?
It's
It
less than
doesn't fit.
26. Yeah.
And is that bad?
Yeah.
That's horrible. That's the worst, worst thing can happen, right?
Uh-huh.
And so that's why type 2 error is really, really bad, typically.
Uh-huh.
And so we summarize, and this is the kind of thing you might see on a final, which is it's better to let a guilty person go free than, do you remember the other side of that?
Let a guilty person go free or
What's the
um
other possibility? Innocent?
innocent is convicted.
Yes. And that's the key difference between a type 1 and a type 2. You never, I mean, in our society, you don't want to, it's not like if you've, ever paid attention to the news, there's other systems where they don't do this, but our system is, we don't want this. We don't want a we don't want an innocent person to ever be convicted. That's why the type 1 error is better. The type 1 error says, okay, you know what? You think you reject H0, you think, oh no, my dress, I better lose some weight, but then you slip it on, you're like, okay, it's fine. That's better than thinking everything's okay. And then you get to prom night and it doesn't fit and it's a horrible situation.
Mm-hmm.
All right. So that is type 1 and type 2 errors. I know we got another hour coming up. I would recommend we spend some time on, I guess, some p-value stuff, maybe more calculator stuff. And I guess voting systems, if you want to go down that road again.
Okay.
Up to you. Well, that's going to do it for us for right now, Julia. So I'm going to go ahead and stop right here.